Alrighty, this lesson is about weather reports, forecasts, kind of official weather information. Where do we get it from? There's a little bit of history in here you'll notice as well, but really that's what it's all about. Usually in this course by now you've learned about kind of weather, like systems and things like that, and where kind of our weather comes from, like what it was some hazardous weather like icing and thunderstorms, stuff like that. What are clouds? What type of clouds there are? How air masses move, with fronts and high pressure and low pressure systems, things like that. Wind, all of those things. Well, where do we get that information from? Okay, so I know this stuff intellectually as a pilot that I need to. Um, Deal with the weather as I can as a pilot, no matter what you're flying, whether it's a plane or a helicopter or a drone or a balloon or glider or whatever. Where do I get this weather from? And so this is what lessons on weather reports and forecasts. It's about official weather. Official weather. Sure, you can go to your phone and say, hey, whatever, Siri or Google or whatever, what's the weather for today? But that's not really official weather. The FAA really wants you to use official weather from the National Weather Service. And there's a little bit of kind of knowledge that goes with being able to read this weather. So we're going to go through these things one at a time. If you have your guided notes, make sure you go through those as well. And here we go. First thing you should know is that there's two types of weather forecasts and information. There's two types of weather information. There's forecasts and there's reports. There's forecasts and reports. Now, forecasts is something that's going to happen in the future. It hasn't happened yet, whereas a report is something that has already happened. So we're going to start with weather reports. These are things that have already happened. And there's one of the main ones is called a METAR, METARS, METAR. And there's three things you should know about METARs. One, it reports about every hour. Unless the weather changes drastically, then they'll issue kind of a special METAR. And they're really only at medium to large airports. In Utah here, like Tooele may have a METAR, or Heber City may have a METAR, but also, Salt Lake International, Ogden, Provo, they have METARs as well. They report ceilings, visibility, precipitation, and wind. So, ceilings is how high certain cloud layers are. Um, it's the lowest overcast or broken layer. It doesn't include scattered clouds or few clouds. Visibility is usually measured in statute miles. It's one of the things in aviation that is statute miles, and that's because weather doesn't just belong to aviation. So these reporting services are reporting it for everybody, not just those of us in aviation. And most everybody in the United States uses statute miles. And precipitation, that's your rains, your snows, drizzle, things like that. And then wind, velocity, and direction. And so wind comes from somewhere. So the wind may be 330 at 10. That means it comes from a heading of 330 out of the northwest, and it's about 10 knots. 10 knots. It's interesting because it's 10 knots, but which is nautical miles per hour, but the visibility is statute miles per hour. So go figure. There you go. So let's kind of look at METARs a little bit here. These are some of the symbols you might see in a METAR, and I'll show you a METAR here in a minute. But like thunderstorms, types of rain, if you see a plus sign or a minus sign in front of things, that means intensity. Like plus means heavy, minus means light. But there's all kinds of symbols there. You can look those up when you have some time. And so you might get a METAR like this. So you have this first part right here. This part is sorry, these animations are going to drive me crazy. There you go. This was the identifier for the airport. In this case, this is a Canadian airport. I think it's because it starts with a C. Ours start with a K in the United States. And then we have the date and time. So this is the fourth day of the month at 2300 Zulu. And if you haven't learned Zulu yet, you should know that it's Universal Time Coordination, or UTC. It's kind of the time in Greenwich, England, and we just use that UTC or Zulu time here in aviation. If it says auto, that just means it was automatically generated. A person didn't generate this, a computer or a system of some kind did. And then we have the wind. The wind in this case is 010 knots. Sorry, 010 degrees, 10 degrees at 9 knots, and then it's gusting to 15 knots. 9 statute miles of visibility. Few clouds at 1,000 feet, broken clouds at 1,600 feet, and overcast clouds at 2,100 feet. So these are hundreds of feet, 1,600 feet, 2,100 feet, 1,000 or 1,000 feet. So broken is the lowest of the broken or overcast. So 1,600 would be our ceiling in this case. And then we have temperature dew point. That's 0 to 9 degrees at 7 degrees. So it's 9 degrees is the temperature in Celsius, and 7 is the dew point in Celsius. And then we have our altimeter setting. It's altimeter 2, 9 or 7 in this case. That is the what you would put in your altimeter, but if you're just looking for barometric pressure in general, that would be 29.97 inches of mercury. And then we have our remarks, and remarks are not anything to get really tied up on, but in this case you have thunderstorms and lightning, temporarily, and it was unavailable. The information, I guess, was unavailable. And then you have the sea level pressure and millibars there. So it's I think it's 11.52 millibars. I don't really remember, but you can look that up. Don't get too wrapped around the axle on remarks. They vary from place to place in a big way, but the rest of this is pretty standard. So that's what a METAR looks like. We'll do some more of those in class. And then so if you're flying along and you have some different options, you can turn your radio into different frequencies, and we're going to talk about what some of those are called right now. But basically, it'll kind of read the weather to you automatically. It's usually a little weather station on the airfield that does that. Some of the ones you might run into is the ATIS. The ATIS is the Automatic Terminal Information Service. We probably, if you've done a lesson with me on airspace or ATC services, you probably have heard of ATIS already, but ATIS is weather plus other information about the terminal area. And when you hear terminal area, you should think airports and flying. It has an automatic recording of the weather at the airport at the 53rd minute of the hour. Now, that's not perfect, so don't take that as gospel, but that's where they shoot for. It comes with a letter designator like Alpha Bravo Victor, so it'll say, Salt Lake information, Mike or whatever, and that way they have the most updated information. If you have information Mike and they say, hey, information November is current, that means that there's a new one out, so you need to go listen to that. And then we have these AWOS systems, and you'll find these more at smaller airports. So it's basically wind, sometimes ceiling information, visibility information, things like that. And then there's ASOS, so AWOS and ASOS, and it's basically the same as the most advanced AWOS, which is AWOS 3, plus some of additional data as well. You can look up what those are later on, but that's generally some, you might get a weather broadcast from one of those things there. Moving down the list here to other kinds of reports. One's a PIREP. The symbol for PIREP is UA. I don't know why. I've never taken the time to look up why a PIREP is called UA. But PIREPs come from pilots, so that's the first thing you should know. So it means that these are pilot reports. Pilots have called into some sort of land-based radio, like an ATC, like TRACON or Center, or maybe to a tower, and they report weather. They're like, hey, it's really bumpy at 38,000 feet, or hey, I experienced wind shear on final approach. And they're either normal UA, which means upper atmosphere, or UUA, which urgent upper atmosphere. So that's what UA stands for. Why that relates to PIREPs, I'm not sure. But maybe it's because the report comes from the upper atmosphere, I guess. I don't know. But it's organized into different parts, and this is sort of the format it'll follow. So first one is location. What are they over, OV? What time is it? What's the altitude or flight level? The type of aircraft, the weather, meaning the flight visibility and weather. So in general, how far can they see and what weather are they experiencing? The temperature aloft in Celsius, the wind velocity, if they know what it is, the turbulence, icing, and remarks. Now I know from a fact, after being an airline pilot myself and giving PIREPs and stuff like that, they don't always give all this information. But ATC already has some of it. Like, they usually know what time it is and what location it is when you call it in. And they usually kind of know some of these things already, like the type of aircraft and stuff. But if they don't know it because you're just a smaller kind of aircraft, or you haven't been talking to them very long, you may need to fill in those blanks. But whatever you give them, if it fits into one of these categories, they will write it down. So here's a PIREP, and this takes a little bit of practice, kind of like the METARs. even more so. But I'm just going to kind of decode it and demystify it a little bit for you. So in this case, they were near this VOR, I guess, which is Hilo Tango Sierra, or sorry, Hotel Tango Sierra. And it was an urgent upper atmosphere. So it was some sort of urgency there. And they're over this airport, the KHTS airport. I'm looking up what that is. KHTS airport is the Tri-State Airport in Wayne County, West Virginia. So there you go. If you already knew that, my apologies. The time was 23:25, and that could be local or Zulu. It just depends. And this is flight level, and it says during D, so that means during descent, I believe. And the type of airplane was a Cessna 525. And the remarks: low-level wind shear there. And they got low-level wind shear, and if you don't remember what wind shear is when the wind just shifts suddenly, so you lose airspeed. And they gained and lost 10 knots, so that's a noticeable amount of wind shear there. And then it was 150 foot on final, so they were 150 feet off the ground, just coming in to land on final for runway 30. I'm guessing into Wayne County Airport, West Virginia. So there you go. So that's how you read that pyre up there. This one, you could be over. This is the VUZ. VOR is a type of VOR. And what they did in this case is they gave us a radial, it looks like, and a distance. So we could go to the VUZ VOR on our chart. And let's see, 1, 2, 3. Where is VUZ? VOR is the Vulcan VOR in, let's see, about where that is. We'll let that look up. But basically, if you find the Vulcan VOR and you go out on the 180 radial, which is south of the VOR, 30 nautical miles, and put a dot on your map, that's where they are. That's where they are right there. And I can't find information about where it is exactly. It doesn't matter. And then the time was 22:48 Zulu. Flight level 370, so it's 37,000 feet. The type was an A380, so a big old Airbus airplane. Sky conditions, the tops of the clouds are at 37,000 feet. Turbulence, negative at 37,000 feet. So they're nice and smooth. They're on top of the clouds. So this is a good one to get. This means, like, hey, if I'm climbing up there real high altitudes, this might be a smooth ride. So be sure to practice those. Definitely look at Figure 14 in your red book if you're taking that exam, because Figure 14 is the one that they use on the exam. And if you know how to decode that one, it shouldn't be a problem. Alrighty. Now we get weather depiction charts. Now these are going to be graphical types of reports. I'm just going to kind of blast through these because they're all very different and very specific in their symbology. And we'll talk more about these in class. There's really not a whole lot in your notes that I've put in these. But we would definitely talk about these in class. But basically you have like your weather depiction charts and your surface analysis charts. Now, weather depiction chart is going to show you things like IFR areas and these little circles that are really hard to see probably on my little screen here. That's sky conditions. So the empty ones means it's clear, and then the ones that are kind of 3/4 full, those are broken. The ones that are half full are scattered clouds, and then they have, different types of information as far as, wind and stuff goes. Now, what's funny is that there'll usually be a key somewhere on here. So if you're reading a test, make sure you look for the key, like the key's down here for this one. It'll tell you a lot of times on the test, on the chart, what you're looking at. This is a surface analysis chart. This is one that I use actually quite a bit when I'm flight instructing, or even when I was working as a commercial pilot, because this shows me large air masses, kind of where they are. So if I'm flying from like one state to another, and I'm flying from high pressure to high pressure, it looks, these lines are pressure gradients, and when pressure gradients are far apart, it means it's little to no wind, and when they're really close together, it means high winds. And if it's moving low, it's counterclockwise. Highs are clockwise, so I'll be able to tell if I'm going to have a headwind or tailwind. But I can tell a lot of stuff by looking at this. I can also see frontal lines like troughs, low pressure, cold fronts, warm fronts, things like that. So lots of information there. I use these a lot in class and with my actual flight students when I'm flight instructing. Here's another one here, a little more blown up, but very useful. Now they have these little wind dots here, these little wind arrows, And that tells you the wind's coming from, like this one down here in New Mexico, the wind's coming from the southwest, and it's only got one little flag there. So usually that means 10 knots. If it's a little bitty flag, it means 5 knots. And then you kind of add those up to know what the velocity and direction roughly is of the wind. Radar summary chart, literally what it is they look at the radar and then kind of draw it out graphically on a map. Most people use actual radar now, but radar summary charts may pop up on your written exams. Here's another one here. This kind of shows the summary of what the radar echoes were doing and their intensities. It also has some wind information here, like this little one over here is moving at 25 knots from the southwest. So if I'm flying it between North Dakota and South Dakota here, I'm going to know that there might be a storm coming along my pathway there. So that way I can see kind of which direction it's also moving without having that kind of animated radar chart that we're all used to seeing on our phones and whatnot. So that's weather reports. Now, forecast, the difference between a report and a forecast. Forecast is like an educated guess of what we believe is getting ready to happen. I do find that aviation weather forecasts tend to be pretty accurate. I typically look at those rather than the regular weather, just if I'm going out skiing or backpacking or anything like that. I like to look at that and just kind of know what the weather's going to do if there's an airport nearby where I'm going to be. But they do update them regularly. That's why they're so accurate. They're not accurate, 36 hours out. I mean, they're accurate, but they're not super accurate. But then they update them every few hours, and when you're looking only 4 hours in the future, they've got a really good guess of what's getting ready to happen. I've found them to be really accurate in my 20 plus years of using them. So let's take a look at some of these. The main one that comes up on tests and when you use in the real world is the TAF. So we'll talk about the TAF in just a second. Prognostic charts. Oh, there's a graphic prognostic chart first in the slides here. Now, this is one that they love to ask you questions on a test. Now, what you should know is you have 4 panes here. You've got a top left, top right, bottom left, and bottom right. So make sure you're looking at the right one as I talk through them here. Now, the top left is low level is the surface. Okay, it's the surface, and it's the 12-hour forecast, okay? For the next 12 hours, they believe this is going to happen. And look at all these little symbols like yellow dashed lines and, turbulence markers. This means that there's turbulence at 50,000 feet or whatever, or sorry, at 5,000 feet, 8,000 feet, 8,000 feet, 12,000 feet, things like that. And but what does this little dotted thing mean in this solid red line? Well, in the middle of the chart here, there's actually a key for them. So make sure you're using those. What most people get wrong on this, let me finish this. So you got 12-hour here, you got 24-hour low level on the upper right. Lower left, you have the 12-hour surface, okay, up to a certain amount of altitude there. And then on the right bottom corner, you have a 24-hour surface one. And so we'll look more closely at these in school. It's really hard to see on my little screen here all the different details of it. But that is definitely a prognostic chart. They're useful. I like looking at them. I look at prog charts online quite a bit. Let's see here. I just type up on Google prog chart, and then I just type in something like KSLC or some airport nearby. And let's see here. And we have one right here. Let's see here. Products, prog charts. I like the modern prog chart. It looks like this. It's very, very, very handy here. I'm going to zoom out a little bit so you can see more. So this is currently the current state of things here. It looks like we got some weather to our west here. So you hit play, and it kind of walks through the days here. I'll put myself up here in the corner. But if you play it the next one, it gives you kind of these times in Zulu down here. So you get like, there we go. So it looks like tomorrow, or at 000 Zulu on the third day. So that's actually very soon from now. And then at 600 Zulu on third day, that's about midnight our time, 11 o'clock tonight. So we're getting ready to get some weather rolling through here for a little bit here. Third day, fourth day down here. I'm looking at the fourth at midnight Zulu. Still kind of a mess. So we're supposed to be getting some weather coming in here. That's interesting. But I use this one a lot, especially when I was getting ready to send students on solo cross countries and stuff. We would look out a few days in advance and kind of see when the weather's going to be out. So if I can get a nice break in the weather here, like on the 5th day at, midnight here, then I know that from midnight till about 6 a.m. was going to be good. So I can kind of guess and pick my battles, you might say, when it comes to like sending students on solos or even just flying myself around out there. Prognostic charts are super helpful. Another very popular one is the TAF. And there's 6 things you should know about TAFs. Number 1, TAF stands for Terminal Aerodrome Forecast. Number 2, they use our forecasts, not predictions. And like I've always said in my other videos, if I'm going too fast, just pause the video. Write down your notes. Number 3 is they're about a 5-mile radius around an airport. So you're not going to get the weather for 20 miles from somewhere, from like Salt Lake. You're just going to get the TAF for about 5 miles around the airport. For a 24 or 30-hour time period, they're updated 4 times a day at these times. And they use the same descriptions that METARs use. All right, so write that down. All right, let's keep rolling here. Now, they mean lots of different things. We'll go over these in class, but you should look what these mean. You may pause and write these down. I may have put them in your notes already too, so make sure you look those up and write those down. This is what a TAF looks like. It looks very similar to a METAR. The biggest difference, and one thing you'll get on test questions, is the times. So like, this is the TAF, and it is for this station here. It's at the 4th day at 23:38 Zulu, and it's for the forecast period is from 500 Zulu on 00 Zulu on the 5th day till 1200 Zulu on the 5th day. 05 is the day, 12 is the time. That's the forecast period. The wind roughly is going to be 290 at 10 knots. Then it's better. P means positive, so better than 6 miles, and overcast at 800 feet. So good visibility, but low ceilings. And then from 500 to 00 to 1200 Zulu, 3 miles, light drizzle is what that means. BR means mist, and overcast at 400 feet. Now, for less than half of that forecast period, it's going to be that. That's why it's called temporary. And then becoming from the 5th hour to the 7th hour, 340 at 6 knots, and then remarks forecast based on an automatic observation. And then it might tell you when the next forecast is, not always. Now, this one down here is a little more standard. That's kind of a wacky one up there. I don't know why we started with that one. But this is from Detroit Western. It's from the 4th day. It was issued on the 4th day at 23:21 Zulu. It's from the 5th day at 0 Zulu to the 6th day at 600 Zulu. So this one spans about 30 hours. Winds 240 at 16, gusting 24, better than 6 miles visibility. Scatter clouds 1600, overcast 2200. Just like the METAR. Then you have forecast period. So if the question was, you're going to fly at 700 Zulu, which forecast should you use? Well, down here you have the 5th day starting at 500, the 5th day starting at 800. So it's probably going to be the 500 one because the 800 one hasn't happened yet. And then you just read what it's going to be during that time period. And these can be oddly spaced. Just depends on when they think the weather's going to change. But for the most part, it looks like the wind's out of the west, southwest, and better than 6 miles visibility the whole time. Low clouds for the first forecast period at 500 Zulu, then at 800 Zulu, sky's clear. Then at 1700 Zulu, broken again at 600. And then at 0000 Zulu, scattered clouds 7,000 feet. So this is a very useful thing to use as well. The TAF is a super useful one to use. Now, graphical forecasts, they're the best source for like an overview of the weather of the region. So, yeah, there's that. All right, we got a few more things to go through here. Now, we'll go into way more detail of this stuff in class, but this is a good introduction for this. We'll go over these prog chart symbols in class, but take some time if you're not going to be in class to look those up. And let's talk about area forecasts. So, like, here's an area forecast right here. Let's see if this one works. Oh, not found. It's outdated. I need to update that link. But an area forecast is. Let me see if I'm pulling up here. Area forecast. They're kind of an old school thing. Here we go. It just takes me to proc charts. Let's see here. This is kind of what it looks like. It's like a long textual thing here. And they just basically give you some information about where this is, the eastern Gulf Coast to the southeast Alaska, or Arkansas or Alaska. Yeah, so, I think that's Alaska, I think. And it says Aramit's valid until 02, the second day at 21:15. And CB means thunderstorms. That's usually pretty standard stuff. And then it's telling you, okay, Aramet for mountain obscuration. The mountains are obscured by clouds. A few at 800 scattered, and it basically gives you kind of a METAR sort of or TAF kind of forecast there. Tells you when its outlook is valid. Turbulence nil, so it means none. Ice and freezing level isolated to moderate icing from 4,000 to 16,000 feet. The freezing level is 3,000 feet. There you go. And then it's talking about Southeast Alaska coastal waters and talk about that stuff again. So it just basically gives you like a breakdown of a large region of weather there. And then we have this convective outlook, marginal, thunderstorm activity, slight chances, yellow, and then just basically it's telling you what different kinds of convection there are. Freezing levels are pretty straightforward. It's just telling you that at 16,000 feet north of this line will be a freezing level, 12,000 feet north of this line, 8,000 feet north of this line. So it's just kind of giving you a rough idea of where the freezing level is. It's just basically plotting where 0 degrees Celsius is around the country along the line there and saying if you're north of that, it's probably going to be at this altitude or higher, and then that altitude or higher up there. Winds and temperature aloft. Okay, so this is an old school one. Now, you may be asking yourself already when we looked at METARs and TAFs and area forecasts, like, why do they encode it? Like, don't we live in an age where we don't pay by the letter or anything? But this is from old teletype machines, and they used to transmit data over phone lines, and they didn't want to use up any more kilobytes than they had to because kilobytes were big files back then. And so they would encode stuff. And this is no different. Now, what you're looking at here is a winds aloft chart. This tells you the winds at 3,000 feet, 6,000 feet, 9,000 feet, 12,000 feet, 18,000 feet, 24,000 feet, etc. And these are stations or airports. Like this is St. Louis down here. Now, saying here at St. Louis at 3,000 feet, the wind is 230 at 8 knots. So it's out of the southwest at 8 knots. Now, there's nothing here because this only reports at 3,000 AGL or higher. So this airport might be greater than 3,000 feet, so it won't be here. And then when you get up here, you get the temperature. So you don't get the temperatures at the 3,000 range, but when you get to the 6,000 higher, you do get the temperatures. You get 270 degrees at 15 knots, -7 degrees. So it gives you the winds and the temperatures aloft. That's really useful for when you're doing flight planning, like cross-country flight planning and stuff like that, because you need to know if I'm going to have a tailwind or a headwind, and what is the temperature, because that affects my true airspeed, my density altitude. And so that'll give you those, all the information you need to figure out that flight planning time and route stuff right there. Now, if you get a 9,900, that means there's no wind, it's calm, but it's still -7. Now, sometimes you get weird ones. Like you can't point to a compass and tell me where 780 degrees is on a compass. So you get some weird ones when you get up to these higher altitudes. So let's talk about that for a second. When the wind is between 100 and 199 knots, the wind direction will be greater than 50. So all you do is subtract 50 from that 77. So we'll go back and look at this one right here that it was pointing at. 75 minus 50 is 25, so the direction is 250, and then you add 100 to the wind, so the wind's 110 knots. That's what that's going to be. And above flight level 240, the temperature is always negative degrees. So there's no negative symbol. They don't waste any kilobytes on that negative symbol. And that's how you get it. So there it is, talking about the 9900. I already told you that. When the wind is greater than 100, subtract 50 from the direction and add 100 to the velocity. So if you had 234502, that means the wind's from 230 at 45 at 2 degrees, right? But if you get 734502, it's from 230 at 145 knots and temperature's 2 degrees. That's because you subtract 50 from the first number, because you can't find a 730 heading on a compass, and you add 100 to the second number. It's like a little clue. If you're like, wait a minute, I can't find this on a compass, yeah, it's probably above 100 knots. That's why. Now there's a graphical version of this. Remember these little arrows are really hard to see on my little screen here. My apologies. So you'll see them up close in class on the big screen. But these are those little darts, and they're having those little flags on them that tell you how fast the wind is. And then the faster the wind, it actually likes to color code it on these particular winds and temperatures aloft charts, and you get to see the velocity of the speed there. All right, airments and SIGMENTs. So airments are issued for information hazards to smaller and VFR aircraft. So airments are for smaller aircraft. They're for moderate icing and turbulence if the wind is greater than 30 knots. It can be any of these. It doesn't have to be all of these. Or, I should say, sustained winds of 30 knots or greater at the surface, or widespread IFR conditions, or extensive mountain obscuration when you can't see the mountains. You don't want to fly into them. Okay. Or volcanic ash with visibility less than 3 statute miles. Sorry. There's only 5 things for airments. I don't know why I did the slides this way. Now, SIGMENTs, weather's potentially hazardous to all aircraft, big and small. Severe icing, severe extreme turbulence, widespread sandstorms, dust storms, volcanic ash with visibility less than 3 statute miles. And they've got different names. There we go. I knew I separated them out. I'm going to fix that real quick. All right. There we go. Now, there's different kinds of SIGMENTs. There's SIGMENT Zulu. There's SIGMENT Tango for turbulence. Zulu, I think, is for icing. So there's Sierra, I think, is for like IFR conditions. But you might get a convective SIGMENTs, and if you remember from our weather lesson, convective SIGMENTs are for thunderstorm activity. So if convective SIGMENT could be issued for tornadoes, lines of thunderstorms, embedded thunderstorms, severe icing, low-level wind shear. Now, I will say this about convective SIGMENTs. If you see convective SIGMENTs along your route, take note. Take note. They are trying to tell you that not only is this significant weather, but it is convective, which means it could be very hazardous because you're probably in the vicinity of some sort of convective activity like a thunderstorm. Here's the graphical chart of it. You can see this if I'm flying from Salt Lake City down to St. George today. I'd be like, oh, there's something up to 40,000 feet. And I could click on that, and it would tell me what it is. And then I think the red is a convective SIGMENT. I can't remember that off the top of my head. We'll have to look that up in class. But yeah, it's giving me there's an airments there, SIGMENTs there, and it's something along my route. It's going to be a bumpy ride, I'm guessing, down to St. George without knowing anything else. I would need to do a little bit more research on that. Turbulence airments. So these are Tango. So like I said, airment Tangos or SIGMENT Tangos. They're for turbulence. And this one up here in the Great Lakes region, from the surface to 8,000 feet, we're having severe to moderate turbulence there. Sierra, these are IFR things, so clouds and mist up here in Maine, over here in western Pennsylvania and West Virginia, clouds, precipitation, mist. So there's IFR through these regions. IFR out here over the ocean, IFR up here in Washington State. Looks clear in Utah on this particular one. Zulu, icing. So icing, 16,000, 25,000. These are for, kind of moderate to severe icing. All right. Now, we still can call, I think as of today, we can still call a telephone briefer up and ask them for a weather briefing. We used to do this all the time, and let me tell you, I learned a lot talking to these guys and girls on the phone. I would call them up. They would tell me all the stuff about my route. They'll tell you NOTAMs. They'll tell you weather. They'll tell you all kinds of stuff, TFRs, whatever. But when you call them up, you call up 1-800-WX-BRIEF, and you call them up and you say, I'm a VFR pilot. I'm going from your route Salt Lake City to Grand Junction, Colorado, and they might ask you for the airport identifiers. Salt Lake City, Sierra Lima Charlie, and Grand Junction is Golf. Juliet and Tango. And type of briefing, standard. If I want a standard briefing, that's typically what you call and ask for. They'll give you all the information they have. If you want an abbreviated briefing, you're like, I just want to know convective segments along my route. That means you've already gotten a briefing and you're just trying to update some information because maybe you got the briefing a couple hours ago. Outlook briefing, you can call them up when it's more than 6 hours in the future. So if I was, say it's like 3 o'clock in the afternoon and I was flying tonight at like 10 p.m., I could call up and get an Outlook briefing to see if I'm even going to need to, put on my clothes and go to the airport tonight, or do I just need to stay home? And they'll typically give you all the information you need after that point. They may ask you some follow-up questions as well. You can also file flight plans with them. And then weather briefings can be obtained by flight service stations and briefers, computer services, aviation apps. You can get weather briefings from 1-800-WXBrief.com instead of the phone number, all kinds of stuff. But you should always remember that the pilots must always stay aware of weather. Weather is one of those things that pilots need to respect and always think about. And you should always use approved methods of getting that weather. Don't just trust any old app you download from the store. Pilots are always learning, just as available weather products are always changing. So always make sure you're familiar with it. I know a lot of pilots use ForeFlight now. I'm actually not good at ForeFlight. I just never really used it a whole lot. So if I was to start using that, I would want to make sure I really understood the weather products that were available on it. Let's talk about these briefings really quickly as well. So you have the standard briefing. This is what they'll give you. We'll talk about this in class. The abbreviated briefing, this is what you get right before you walk out the door. You call them up and say, hey, I just want to get an updated abbreviated briefing for this route. And they'll tell them specifically what you want. I want convective segments, airments. I want to know any icing, turbulence along my route, anything like that. And when you're in flight, you can update your weather in flight. So you can contact Flight Service Station on nearby VOR, or what's called an RCO, which stands for Remote Communications Outlet. The frequency for that will be printed on the charts. You can always call it Flight Watch 122.0 until 2016, and then it was decommissioned. So now it's gone. Now, last thing we're talking about is FIS. I just added this because there was some questions about it I saw at one point in the test bank. But flight service stations provide weather advisories on 122.2, apparently. I've never used it. FSS provides information regarding actual weather and thunderstorm activity. It is designed to be a continual exchange of information on winds, turbulence, visibility, icing, and stuff. So it's just basically an open channel for you to talk to weather briefings. Now, this system lacks the updating capability. So you got to be careful if you're using like a FIS-B. So you may have a FIS-B type broadcast that is on like a screen or something in your airplane. So you just got to be really careful for that. So you should know that FIS information is intended for advisory use in long and near-term planning and decision making. It doesn't update in real time. It's not radar like a radar mounted to the front of a jet. It's a little it's dated information. It could be like 15 minutes, 20 minutes old. So if you're trying to dodge a thunderstorm in IFR and you're like, oh, according to the FIS, we're ahead of it, you got to keep in mind that data could be minutes old and you could be right on the edge of it. So just keep that in mind. You could some FIS products in the cockpit have airments and segments they can draw out for you. NEXRAD is a really popular one on like the G1000, but it is FIS. Keep in mind, and there it is right there. Pilots should be aware that NEXRAD uplink may be up to 20 minutes old, so just be careful with that. And that's about it for the slides and for the notes. We go into way more detail on this stuff in class. You get a lot more practice reading things. But I just wanted to make sure that you had a chance to update your notes before you get to class so you can participate and really get the most out of this class that you can. This stuff is critical. I'll be honest with you, weather is just so critical. It's a 10 out of 10 in terms of importance. Some of these tools you'll use more than others, but weather information by itself is definitely a 10 out of 10. So hopefully you're going to get that down and be able to use that very quickly. Thanks.